talking about projectile motion. So projectile motion is the motion where an object is moving in after you throw it, or a force is applied to it in two different scenarios. The first scenarios, I will call it horizontal projectile motion, which is when you throw an object off a cliff or an edge. So it will have the motion or the projectile curvature like this as it drops towards the ground. And the second motion, I will call it vertical projectile motion, which is when you shoot it from the ground up, and it will have a slightly diagonal motion. So I will call this vertical projectile motion, and it will have the curvature like this, like when you throw a ball or shooting a cannonball. And there is a lot of formula relating to calculate a lot of different values within the motion, but you have to remember three of the most important one, which is A is the acceleration, V is the final velocity, and U is the initial velocity, and T is the time. The second one is this formula is relating the three values that we have talked before, but with distance. And the final one is this three formula is the basis that will be formed the other formula around this. We just plugged in the numbers and we can find it. Consider the vertical projectile motion. So we have this curvature representing its path throughout the air. So the initial velocity, we'll call it z because it is diagonal. This component can be broken down into vertical components and horizontal components, which we'll call y and x. So and between this is we'll call this angle alpha. So to know what is the values of the vertical component, for example, we have the initial speed. For the y component, it will be sine of alpha times z. This is basic trigonometry. You can see a right triangle here. And the initial speed of x is cos times z. And relating these two components together is crucial, and is what we understand it is how we can calculate a lot of values like the distance or the maximum heights of this motion. One more important things that we need to understand is throughout this motion, the initial speed of the horizontal component, which is x, is constant throughout the motion and within the air. Constant velocity throughout the motion, and only y is varied. Knowing this, we can calculate a lot more and understand which to plug in into which formula, the basis formula up here. So the first thing that we have to calculate, or it is most often to be shown up as a question in your exam paper, is the time of flight of the object. So to calculate this, we only need to consider the vertical velocity because the time is only affected by the gravity that is pulling it down, which acts in a vertical direction, and that's why you only need to consider the y-axis. So I'm gonna make a note here. Only need to consider vertical velocity. Yes, and relating it back to these three original formula, we would use the first one here, which is the final velocity is 0 as it reaches the maximum height, which is this point. So from this we can know that this t right here is only the t to reach the maximum height, and so in order to find the time of flight we have to time it by 2, because in terms of time this two part is equal. And so maximum height is velocity of maximum height is 0 minus initial velocity of the vertical component is of course sine of alpha times z, and t is finite and a is minus 9.8, because as I have stated before, it is only affected by gravity and it is pulling it down, so acceleration is minus 9.8. And we have the time here, so make time the subject, it would be yes. And in order to find the time of flight, we need to time this by 2, which is 2t equals to 2 sine alpha times z which is equal to 9.8. Yes, so this is the first formula here, and it is very important in your exam. And just remember that this t is time to reach maximum height. And it will come up in your test as a question as well. The next thing that they will ask you to measure is the maximum height of the object that could reach. So we will use the second formula here, which is and as I have stated before, maximum height v will be equal to 0, so it will be v equals to 0, and this time we also only need to consider the vertical axis, which will be times z, and a will again be minus 9.8. And we have, so plugging it in, we will have this So this is the second formula here. The math is quite intuitive, and if you write it all down, it will be much more easier. The last value that the test will ask you to calculate and in the syllabus will be the range of the motion. So the range is basically the horizontal distance that the object traveled. So it will be this distance right here. This will be the range. So we already knew that the horizontal velocity is constant. So we use the simple distance formula, the most simple one, which is distance equals velocity times time. So, and this velocity is of course the horizontal initial velocity, so it would be cos alpha times z times t. And this t we can plug them from the previous formula, which is this, into which is times 2 sine alpha times z over 9.8. Yes. And the math is more difficult and a lot more complex when you try to simplify this down. So it will be s2 times and so this will be the range. This is the formula for the range. So from this step to this step, mathematically is very complicated. You have to use a trigonometry identity to be able to jump from this step to this step, and I will explain it down here, and if you don't want to, you can skip ahead. So so basically this is the trigonometry identity. So you just kind of have to know this, right? So from this step we have sine of x plus y equals to, which is this part right here, 2 times so you can see the correlation between these two. This is the original one, and this is the one we have, and this is basically the same thing. With cos alpha and cos alpha the same, it's basically the same thing. Oh wait. And with alpha and alpha the same, it's basically this trigonometry identity, and so we have sine of alpha plus alpha, because xy is the angle, would be equals to this, and we have that sine 2 alpha is equals to 2 sine 2 alpha is equals to 2 times cos alpha times sin alpha, which is this thing, just this thing. That's why we have sine 2a here, 2 alpha here.